Hello and welcome to a video on basic fraction concepts where we will focus on being at an early elementary school level, just being introduced to fractions, but having seen the part of a whole concept without shortcuts and formulas still. So that's where we're at. Now, if we should have done a basic comparison of fractions that you can draw a rectangle for. If you have 3/4, you can very easily break them up into 4 equal slices, like so, the part of a whole concept. And if you have 2/3, you can break them up into 3 equal pieces, maybe horizontally as you prefer, and then easily compare these two. So that is something you would know already going into this. However, if we have less convenient fractions where drawing out the rectangles and completely visualizing the part of a whole concept is less convenient, what do we do if we want to compare these two and see which one is bigger and which one is smaller at this early elementary school level?
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.
We can still conceptualize the idea without explicitly drawing the whole thing. So if we want to just visualize the part of a whole concept of 12/17, I'm looking for a rectangle, you can imagine splitting it up into 17 equal pieces, and then we have, let's say here, we have 12 of these little pieces. And if we compare that to 12/19, without completely drawing the rectangle, you have the foundation to understand what we're doing here. And we have 12 of these pieces as well. So there's a reason that the numerators are the same, because that requires that I simply understand an individual little slice. If I put it over here, that's a single piece. And I visualize or imagine a single piece in the other fraction. The part of a whole concept means that I split this rectangle, this basic unit rectangle, into 17 equal pieces, whereas the one on the right I split into 19 equal pieces. So a piece on the right is smaller than the piece on a single piece on the left. And because I have 12 of each, I can conclude, well, 12 of the larger pieces will be more in terms of coverage of a rectangle than 12 of a smaller piece. And then I can conclude in here, let me erase this, that 12/17 are larger than 12/19, and I put the appropriate inequality to state the comparison. So we're extending the smaller convenient fractions where we can completely draw it and completely compare them to the same concept, but more conceptually doing it than explicitly visualizing the fraction entirely. We can compare other fractions as well. Now, we can't necessarily do this for any random two fractions. There comes a point where it is more efficient to convert them to a common denominator or take more formulaic approaches as the numbers get less convenient. But there's still some structure here. So I see here that in the previous example, the numerators were the same, and I could reason based on how the denominators compared, which fraction was larger. I can flip that around to arguably an easier one, where the denominators are the same. So if I now visualize, and perhaps it might make sense to start with something like this before the other one, a little easier perhaps. Here, the rectangle is split up into 19 pieces. Compare that to a rectangle that's split up in the same number of pieces. So here, a single piece is the same single piece, because the denominators are the same. Here I am going to have, whether I explicitly draw it or not, have 7 pieces. And here I will have 8 pieces. Now remember, at this early elementary school level, the number sense isn't completely established yet, so it is very difficult at that level potentially. And because I've now essentially converted these fractions to, comparing the fractions to comparing the integers 7 and 8. So because 8 is more than 7, I can conclude, I'm not writing all of this out in words, but it would be perhaps helpful to do so in full sentences as well. I can conclude that 8/19 are greater than 7/19. So there's some structure between these, in that the numerator or the denominator is the same between the two. I can have something slightly more complicated with this one, and there's still some structure behind these fractions. They're not random, in that I'm comparing two fractions where the numerator is specifically 1 less than the denominator. Now this can be extended, but this is a good next step example. So to make sense of this, I could perhaps first look at some easier fractions, like a half versus 2/3 versus 3/4, 4/5, and so on. Having this similar pattern. And then seeing, well, what's missing here? Let's say missing in terms of what I have of a rectangle. I have half of a rectangle, so a half is missing. I have 2/3 of a rectangle, so a third of the rectangle is missing. 3/4, a quarter of the rectangle is missing, and a fifth is missing, and so on. So the missing amounts, or the missing space, is decreasing, because again, I can rely on my previous examples where the numerators are the same and the denominators are different. Then the larger denominator is the smaller quantity. So the missing amount decreases. So the sequence here that I'm making, where the denominators increase but the numerator is always 1 less, this is an increasing sequence. So that means the larger denominator with this structure, it has the bigger portion of a rectangle. And so I can say here, based on that reasoning, I can extend this to any two. Here, 20 is the larger of the denominators, so 19/20 are greater than 18/19, based on this reasoning that I can extend from the easier, more familiar fractions. And of course, writing this out to make clear you understand the reasoning is certainly beneficial. In the interest of saving time, I'm just sort of talking through it very quickly. We can also go to something arguably looking a little bit more complicated, but also not, by comparing it to a reference simple fraction. In this case, I can use a half and compare a half to 13/18 and separately to 29 over 62, and perhaps make a conclusion, again, not always, but it's another strategy to help me compare the original, sort of a transitive way of thinking. So if I compare 13 over 18 to a half, well, the equivalent fraction to a half would be 9 over 18. And when I compare those two, I see that, 13/18, again, based on my previous experience now that I've built up, is larger than 9 over 18, and so a half as well. So I can put that in there, that this is the larger one. If I then separately compare a half to 29 over 62, well, I'm in eraser mode, there we go. A half would equivalently be 31 over 62. And if I compare those, now the denominator is the same, so it's easier to compare. Erasing this, I can see, well, 29 is smaller than 31, and therefore that's the smaller amount, therefore less than a half. So I've made the little chain here that, I'll do it the other way around, from smaller to larger, that 29 over 62 sits on the lower side of a half, but 13 over 18 sits on the higher side. And therefore I can conclude, or therefore I can compare these original two fractions by linking it to a familiar, easier fraction. So that's another strategy, that we can very quickly compare two fractions without specifically drawing out the rectangles, different strategies, leveling up from that basic elementary school concept, slowly inching towards more complicated things. I can then extend this as our last example to arranging a whole bunch of fractions like these 4, for example. Now it does depend on what they are, and in some cases two fractions might be so close together that it's not as easy to quickly do it, and you can take more elaborate, more sophisticated, sophisticated methods like converting them to decimals and thinking in that sense, but basing it at this stage on the part of a whole concept builds that foundation very nicely. So if I make a little number line here to just give myself some structure, number line goes on forever here, I can use some easy reference points, like maybe, well, there's no negative numbers here, so let's put the 0 over there, and maybe 1 over there. And I can see, well, the first 3 are all proper fractions, so they will fit in here somewhere, whereas 8 over 7 is an improper fraction, and 8 over 7 is going to be on this side, 7, on its own. So I know already, without doing nearly anything, that that's going to be the larger of all of these, the largest of all of these. So then my problem is reduced to simply figuring out and sorting these 3. Now I can compare this one to an easy fraction that I have, which is 1/3, and I know 1/3 sits over here roughly. I have a significant portion of a whole missing, so it's far away from 1 and closer to 0. Whereas 12 over 13 is very close to 1, and 12 over 13 will sit somewhere over here. Now, of course, it depends on these, that in some cases it might not be as obvious, but we've seen with our one of our previous examples, which I think was this one, how we can compare if there is a specific pattern or structure between the numerator and denominator. So we can use our previous experience to make little conclusions and start systematically putting these in roughly the right place. Now 21 over 40, I can compare this to 20 over 40, which is a half, and say, well, okay, this is very close to a half, and a half is quite a way away from 1/3. And so I can put 21 over 40 there. Now it does depend. In some cases, if I just take a random list of a bunch of fractions, then in some cases, some of them could be very close, and I might not be 100% sure of this sorting. But in most cases, just understanding the different strategies to compare fractions, I can have a quick sort and a very solid sense of how these fractions compare, simply extending the original part of a whole concept to slightly more sophisticated comparison strategies, like this one as well that we went through, and combining them based on the fractions I'm working with. So hopefully that gives you some more experience and more variety to build that number sense foundation when it comes to fractions. Until next time, thank you very much.